Today, let's go beyond and to the roots of exploration with Bruce Dorminey, a science journalist and author who primarily covers aerospace, astronomy, and astrophysics. He's a regular contributor to Astronomy magazine, and since 2012, he's written a regular technology column for Forbes magazine. He's also a correspondent for Renewable Energy World. Writer of Distant Wanderers, The Search for Planets Beyond the Solar System, he was the 1998 winner in the Royal Aeronautical Society's Aerospace Journalist of the Year Awards, as well as a founding team member of the NASA Astrobiology Institute's Science Communication Focus Group. Let's go beyond with Bruce Dorminey.
Go beyond your horizons.
All right, here we are with Bruce Dorminey. Bruce, thank you for connecting to the spacecraft.
Hi, thank you. Thank you for having me.
Yeah, pleasure.
Thank you for having me on board, I should say, right?
On board, exactly.
Yes, I'm on board. Okay.
On board. So, Bruce, I've really enjoyed reading a lot of your writing and articles. And in one of your latest articles, you talk about Magellan's journey, the Portuguese explorer, to the Indies, also doing the first circumnavigation of the Earth. And in your article, we read that the Magellan's journey would have been comparatively harder than our future trip to Mars. Do you think, this made me think about risk, risk at those times in the year 1519 and risk today. Do you think that in previous centuries, human beings were more willing to take risks? Are our society today, is it more risk averse? Is this good? Is it inevitable? What do you think?
Well, I think if you look back in Magellan's day, Magellan set out with something like 250 crew members with something like 5 ships, if I remember correctly. Mm-hmm. And Magellan himself was killed in the Philippines. And the issue was that Magellan was Portuguese, but the Portuguese would not fund his voyage. It was a voyage to find another route to the Spice Islands, the Moluccas. They knew that there was an eastern route to the Moluccas, but the Spanish wanted a western route, and this was due to a treaty called the Treaty of Tordesillas.
Tordesillas, yeah,
which actually divided the world into longitudinal quadrants. On one side, everything on the western side, everything belonged to the Spanish. The Spanish claimed it, and on the east, everything belonged to the Portuguese. Mm-hmm. I mean, these are two countries. I mean, think about it. Who just divided the world up between themselves. Forget about the rest of Europe or anybody else. They divided it up.
Crazy to think that Spain and Portugal had almost everything. Yeah,
that's right. And so Magellan wanted to find. He set out from Spain and sailed around. The tip of South America and up the west coast of South America. What we know today is South America. And then headed west, and he did not reach the Moluccas. He reached the Philippines first, and he was very distraught. Apparently, according to the historians I consulted in Lisbon, I'm not a historian, but this is what I was told. He was very distraught because he realized that the Spice Islands were on the Portuguese side and not the Spanish side. And he returned the same way he came, back on the western side, back to Spain.
One question. Wait a minute. Why was it a problem to find that they were on the Portuguese side and not the Spanish side?
Because the Spanish wanted to claim the Spice Islands for themselves. And if they were on the west, if they were in their western territory, longitudinal territory, then they could claim the the Spice Islands, the Moluccas for themselves.
Okay. Yeah.
And the problem at that time was longitude as we know it today was not very advanced. They had some methods of determining crude longitudinal measurements, but not like we have today with chronometers and timekeeping.
Yeah.
And so this is what happened. And in fact, we're taught in grade school that Magellan was the first to circumnavigate the world, but that's not correct. He actually was killed in the Philippines, and his crew, instead of returning to the west, went back the way that was known from the Philippines to the Moluccas, back to Spain. And so that's that's a very strange story.
It is.
And I can't imagine anyone making a trip to Mars or any other planet, just for territorial reasons, in the same way that seemed to have spurred the age of discovery. But it wasn't just territorial. It was also, they wanted to find a more efficient way or easier way to get to the Spice Islands, because there were spices that were important to them.
Yeah.
There were religious reasons. They were actually looking for fellow Christians that might have been become Christian at that time, but without their knowledge in other parts of the world. And you have to remember that the Spice Islands and the Moluccas and the coast of India, what we now know as India, I assume and in the 16th century, I don't know if the country we now know as India is India, but I don't know if the name was India at that time. But it was a vast trading network already. It was bustling, and this is something that both the Portuguese and the Spanish were aware of, and they wanted to get in on this market. And so I hope that makes it a little bit clearer. As far as the casualties, crew of 250, something like 18 returned. So those are casualties and deaths.
So 18, so they were 200 and something, and only 18 returned.
That's right.
Wow.
So that's something that today we're a little bit hopefully more civilized. I don't think anyone taking a space voyage would accept those kinds of risk to human life. Exactly. That's not taking anything away from the early astronauts who risked their lives in tin cans, pretty much. I don't know if you call them tin cans, but and with a very minimal computing power. I mean, I believe that the computer on board the Apollo 11 spacecraft, the first to land on the moon in 1969, had less computing power than, much less than one of our smartphones, like the most basic smartphone. So I think if we eventually get to Mars, if we return to the moon and eventually get to Mars, I think, a lot of these risk factors, we're going to find ways to mitigate them. And, we don't, there are a lot of factors that we haven't successfully mitigated, and we're still working on that.
Very interesting. Yeah. So definitely in terms of risk, you point out that today people would not accept such a huge risk or such an amount of casualties. There is no way. So our society certainly has a lower tolerance to this.
That's right. And I don't know the details of the crew who were on these early voyages. I would imagine a large number of them probably, maybe they went against their will, maybe they had no choice, maybe for economic reasons, maybe they were coerced. I'm not a historian, but maybe some of them were not even volunteers. Who knows?
Could be. So anyway, it's fascinating.
It was a very different time, a very different culture, and I think we're more socially aware and more evolved in a social sense, and in a moral sense.
Perfect. So the largest ocean on Earth was crossed side to side on the first attempt at that time. Right. Now, despite being potentially easier, do you think that our first attempt at reaching Mars with humans will also be successful? What are the odds?
I think it'll be, I would put, by the time we're ready to launch, we'll have done so many computer simulations and so many tests of the engines. And I think personally, as a child of the Apollo era, I was telling you today that, I actually watched these Apollo launches and the Apollo program, from Gemini on.
Amazing.
Live. I mean, I watched the first.
Can you imagine to watch live?
I watched them live on television. What I mean,
yeah, on television, but live,
yeah, live. I mean, I'm old enough to have remembered all that, and these were fabulous. I mean, we were just captivated. I just.
What was your feeling? What were you feeling?
The whole world.
Yeah.
I mean, because there was nothing like it. It was the best television on. It was fabulous.
I mean, were people conscious of the importance, the uniqueness of the moment? Yeah.
Oh, absolutely, no question. And I can remember being I wrote in this one of my columns. I think when Apollo 8 was the first to circle the moon. I remember actually, being called in by a principal to the library. It was after hours at the middle school I was attending, and he turned the TV on so I could see it because he didn't want me to miss it. And it was like we were just, people stop what they're doing. Apollo 8 circling the moon, and you're seeing, these fabulous pictures. There was nothing like it.
Fantastic.
And so you have to forgive me as someone who watched all this live. When people were really risking their lives. And I'm not saying the astronauts 2 days from now or tomorrow who are going to be on SpaceX. I mean, there are always risks to space flight. And particularly, this is the first time a commercial spacecraft has carried astronauts to the space station. There's always risk, but I think the risk have been mitigated, and I would argue there's much less risk for this launch.
So you think that our first attempt to get to Mars may be successful then, because the risks are much more controlled?
I think I would think so. I mean, of course, anything can go wrong.
Yeah.
And I think I wrote a column on this. I think that the psychological risks.
Yeah, I wanted to ask you about that because you told us before
that was one of my early columns for Forbes, the psychological risks. And that came about because in the early 2000s, I had the pleasure of interviewing Harrison Jack Schmitt, the last man to actually step out onto the lunar surface, Apollo 17.
Beautiful.
And at in the lobby of an Albuquerque airport hotel, he showed up in his. He used to live he's from New Mexico, and I think he still used to live in the Albuquerque, New Mexico area. And he shows up in his red Ford pickup truck and comes in, and we sit, just the two of us. And he's the first astronaut who I had the pleasure of meeting who actually walked on the face of the moon.
That's beautiful.
And so I had like two or three questions for him. And the first was, when you were actually on the way to the moon and you look back at Earth and you realize how far you are from Earth, what did that feel like? And he said, well, it was beautiful. And I said, what about, when you were on the lunar surface and you took a moment to actually realize, what did that feel like? I mean, did you just had to pinch yourself, I'm on the moon, did you just kind of just freak out? And, I mean, psychologically, lesser men would probably, or lesser women might just, they kind of have to realize I'm on the top of Everest. They might freak out. They might realize I'm on the lunar surface, you know, in the Taurus Littrow Valley, surrounded by these lunar mountains. You know, what does that do psychologically to a person?
Yeah.
And, you know, a lot of people would probably just be so overwhelmed. They just have to say, you know, who knows what could happen? They might go to pieces. They might have an anxiety attack. You know,
Exactly. So
and so the bottom line is, his response was classic. NASA, and he said, "Hey, we were there to do a job, and we did it, and obviously they did, and our time on the lunar surface on that EVA was so structured that we didn't have the time to sit around thinking about that, you know, maybe afterwards." So I hope that I hope that kind of answers your question.
Yeah, that's great. So that is, talking about the moon. Now, if we think of a trip to Mars, what do you think about the psychological factors during an eventual trip to Mars that is going to last many, many months? Do you think we can really prepare from Earth? Can we really predict what are going to be the psychological consequences of such a long trip of many, many months on the way to Mars? Will there be surprises from a psychological standpoint?
Well, I think that in a weird way, the International Space Station has helped us with that.
Okay.
Because, we have astronauts that have spent many months. I can't remember the record, but I think it's approaching a year in space.
Yeah.
And of course, it's in low Earth orbit, or maybe technically it's not low Earth orbit. It's in Earth orbit, and that's been very helpful, not only to determine the psychological factors, but also the medical factors. And I think that's maybe the wild card, the psychological factor, because you think about a trip to Mars. All right. So the shortest journey is going to take 6 months if you use chemical propulsion. I wrote an article on this as well, for advocating for nuclear propulsion. And my view is that to get to Mars, we really, need to do make that trip, cut it down from 6 months to 4 months.
How do you do that? How do you cut it to 4?
Using nuclear propulsion. Maybe chemical propulsion to get us into Earth orbit, and then nuclear propulsion from Earth orbit, or maybe use a lunar gateway. We're talking about, to get to the lunar orbit, and then launch from lunar orbit using nuclear propulsion. But because the moon is only 4 days away, that's really nothing.
Away. That's a weekend.
But I think you've hit on something, and that is the wild card. The other wild card is mitigating cosmic rays, galactic cosmic rays, which are the lethal ones. I think NASA, the bottom line, though, I think that NASA or ESA, whoever ends up, or SpaceX even, whoever ends up sending the first cruise to Mars, I think they're going to have mitigated the risk factors to such an extent that I don't, there would be no comparison with Magellan's first trip across the Pacific, which is what prompted this historian to say, a trip to Mars is going to be less risky than a trip across the Pacific. And you can see his argument. It's interesting maybe it's not an apt comparison, but I wrote the article and I coined the headline because, this is maybe this will jumpstart new debate about getting to Mars. And aside from Elon Musk, we don't hear a lot about that. I mean, we hear a lot of dates put forth by both ESA and NASA about, projected timelines for putting crews on Mars. But it's not the same thing as when Kennedy announced in the early 60s the goal was to return a man from the lunar surface and back safely by the end of the decade. And, we did that amazingly. It was a Cold War effort. And so it's no surprise that we didn't really return. I think it's sad that we didn't return. I think we've squandered a lot of time in which we could have been using the moon for natural resources and for astronomy. But and it would also have been, the lunar surface would have also been a fabulous place to practice, simply getting to and from a planetary surface, and make it so routine that when we did go to Mars, we would say, hey, maybe this is old hat.
Yeah. Okay, so now let's imagine that we get to Mars. When we get to Mars, what do you think about the whole terraforming concept, transforming Mars and its atmosphere into a place where humans can live? What do you think of the terraforming concept? Do you think it's actually viable?
I actually wrote about this in kind of an ironic article back in the mid-90s, which interviewed a couple of gentlemen at the British Interplanetary Society about terraforming Mars, and the headline was something like this: this Englishman wants to put a roof over Mars.
A roof over Mars.
A roof over Mars. It was one of my most successful articles, and
cool.
I think that's, we're a long way from that, and I'm personally, I'm not sure that we should do that within the first century.
Why?
I've kind of changed my mind about that. I think that we should view Mars in the same way that we view the moon, as a beautiful natural resource, in the same way that we view Yellowstone National Park in a way. Maybe we should have some sort of commercial development, but these are, this is part of our solar system history. And we can learn a lot, scientifically from the exploration of these nearby bodies. I mean, I can include Mars as a nearby body, and I think the rush to terraform it before we fully understand its science value would be a mistake. And I think, let's say, even if we did want to terraform it, I think realistically, I'm just giving a guesstimate. I would say we're a couple of 100 years away. I could be.
And what do you think of those who say that we may actually need a second home at some point, because maybe the Earth will become, people won't be able to live anymore, and we will actually need to look for a second home. If that really happened, is it actually realistic? You say a couple of 100 years away, so it's actually viable. It's actually possible to do this terraforming.
Well, no, I think in a couple of 100 years we could have platforms in space.
Platforms
some
in space.
Lagrangian point that is orbitally stable, and with using some sort of artificial gravity.
So living like in giant
I think
stations.
Platforms in space. If we need to get off Earth, but I can't see, the need to run, from our own planet. I mean, I think there are many ways that we can mitigate climate change or pollution here, and get very creative about it. And
that would be much better. Yeah, I agree. Okay, now let's go back to Earth. Let's go back to Earth for a second. I'm very curious about something. When we think about exoplanets, those planets that are outside of our solar system, that are orbiting other stars far away, and we're trying to detect signs of life, but they are so far away from us, and it's really difficult to detect signs of molecules and life from so far away. But you just published an article recently in which you talk about something really intriguing and really beautiful, that is about using color and the color spectra to try to detect signs of life and chemistry in these exoplanets, right? Could you tell us a bit?
Well, that would be, obviously it would be microbial life, first of all. And you use, you detect ozone or methane, carbon dioxide, which can all be oxygen, which can all be signs of biosignatures, but it's very complicated. And it's become, since I wrote my book on exoplanets, A Distant Wanderers, A Search for Planets Beyond the Solar System,
Yeah.
at that time there were only 60 known exoplanets, something around there.
Mhm.
And they were all basically hot Jupiters, because those were the first we were capable of detecting. Now we're on the verge of detecting, real Earth analogs. But even if you detect, an analog of Earth in a habitable zone, which means that a habitable zone simply means that you're capable of having liquid water at the surface.
Mhm.
It doesn't mean that detecting microbial life spectroscopically with ground and space-based telescopes is going to be easy. And the best I would say in 10 years' time we could hope for is that somebody has a cocktail of chemical species that they've detected, a chemical species in an atmosphere that could possibly be interpreted as indicative of some sort of microbial life,
Hmm.
and they're presenting a paper at an astronomical meeting, and it causes a great stir and debate. But until we go there, until anybody goes there, you can't be absolutely positive
Yeah.
that this is the frustrating thing, and this is kind of what I realized. Detecting microbial life, you're going to be detecting species, and maybe using color as a part of that detection method. But how are you actually, unless you have an electron microscope on some sort of equipment that you could send into the atmosphere to capture samples, and you might detect microbes in an exoplanetary atmosphere. How are you actually going to be positive that you can say 100%
Yeah.
with certainty
Yeah.
this
Yeah.
is life? This is life. Do you see my point?
Yeah. This reminds me of the issue with the ocean in Europa, the moon of Jupiter. That when they sent the probe there, they got the first signs that there may be an ocean under the surface of Europa, but
Right.
they couldn't still be completely sure. Then they did more studies, then they found more evidence, but still not totally sure. Now they found even more evidence in the data, and it's what you say. You need multiple amounts of different types of evidence before you are completely sure. So when you are looking at exoplanets that are even farther away.
But let me just butt in there. With Enceladus, for instance, and some of these lunar, these outer planet lunar bodies, NASA and ESA are both working on flyby missions that would actually sample some of these plumes. These
That's right.
plumes of spewing gas and liquid that are spewing forth volcanically from the surface.
Mm-hmm.
And if they can sample these, they may be able to do some sort of in situ analysis and send back the data and say, hey, this is definitely, signs of life, or maybe even life. And I think if we found evidence for microbial life on Mars, if we find evidence for microbial, good solid evidence, we have a good chance. I personally think we're going to find microfossils on Mars. I just think if we look hard enough, maybe it's going to take deep drilling. I think, I think, that should, the sample return mission, I do think we're going to find microfossils on Mars. And what we could conclude from that is if our next, habitable planet over Mars, which once was probably habitable for a brief period, if it has microbial life, even if it has microbial life, the chances of life evolving twice, in the same solar system, and I don't think it's necessarily going to mean that it came from Mars, and I don't think the life from Mars is going to have seeded Earth or vice versa. I think it's probably going to have evolved independently. That's my personal opinion. And if you get that, that means that life, ubiquitous, that means that microbial life, at least, is going to be pretty ubiquitous.
Yeah.
Now, by the same token, we haven't touched on SETI, or the search for
Let's do
for
it.
intelligent life, I think that intelligent life is going to be much more rare. I don't think it's impossible, but I think it's going to be much more rare. And there was just a paper by David Kipping at Columbia University, which I also posted a piece on, which said that, you know, the odds are 3-2 against intelligent life.
3-2 against intelligent life.
Yeah, being common.
Ubiquitous. Yeah, being common. Yeah.
He doesn't preclude it existing, but it's not going to be as common as microbial life.
So we may have won the lottery, basically, somehow.
I think that we're a very special place, but you know, the argument is based on statistics and probability.
Yeah, we don't know.
You know, we live in a galaxy, and people don't realize, you know, we live in a galaxy that has, you know, it's still a star-forming galaxy. There's still, you know, sun-like stars being born. There's still, you know, Earth-like planets being formed, and you know, this has been going on, you know, since the birth of the universe. You know, over time immemorial, not time immemorial, but for about 14 billion years. Okay. Yeah. And what we can say now, what we learn now, is that we keep pushing the timeline back for the formation of galaxies. You know, it used to be that they thought years ago that galaxies didn't form until maybe 2 billion years after the Big Bang. Now they pushed it back to about 500 million years after the Big Bang, 500 million years after the Big Bang, the first galaxies formed. Yeah. And, you know, so we think that the cosmos was primed for life from very early times. And, you know, statistically, we have something like 400 billion stars in our own galaxy.
400 billion stars?
Yeah, 400 billion.
Wow.
I mean, 25 years ago, if you looked at an astronomy textbook, or 30 years ago, they would say 100 billion, but we have revised that upwards. Conservatively, an astronomy textbook will probably say 200 billion, but if you talk to people who study star formation in our galaxy, they're going to push it up. They're going to push it up. I knew that I got that 400 billion figure from doing my own research on my book. Now, at the time I did my book, there were something like 400 billion galaxies known. And now that number has been pushed up. Okay, we're just one grand spiral with 400 billion stars. There are literally, you know, almost an innumerable number of galaxies, full-on galaxies. I don't mean dwarf galaxies. I mean full-on ellipticals, full-on spirals, grand spirals, the most beautiful things you've ever seen. They're all filled with stars. The same physics applies to them. The same chemical species, the same, you know, bowling ball madness to create these planets around these stars. So you have to be, you know, I would be pretty incredulous to think that the universe is not filled with microbial life, and frankly, the universe is not filled with intelligent life of some sort.
Yeah, and do you think, Bruce, that we prepared? Just imagine for a second, let's imagine that we got, you know, maybe a radio signal or whatever, you know, some evidence of intelligent life. Do you think that we as human beings, our species, are we prepared to face that event, such an event, to receive maybe a signal and a piece of evidence that there is other intelligent species out there? Are we prepared for something like that? What would happen if such event took place?
I think personally, I think we're prepared. I think most people believe, as I believe, that that the likelihood of there being intelligent life out there, they probably already believe that. You know, it just hasn't been confirmed. When you're faced with it, but you have to remember, let's say we receive a signal, you know, an intelligent signal, and we confirm it's an intelligent signal. Yeah. Number one, we're probably going to have a hell of a time interpreting that signal, even if it comes through the radio, which may not necessarily come. Yeah. And let's say it's from 100 light years away. Okay, so you have to remember, you know, the signal was sent 100 years ago. All right, we receive it. So and we're probably not going to be able to interpret it.
Yeah.
And let's say we don't ever interpret it, but we decide to respond, and we have a good idea of from where it came, and we send a return signal, which it may or may not. I mean, Stephen Hawking was against sending signals out in the cosmos.
Thought it was risky. Yeah.
Exactly, and I see his point, and I kind of agree.
Yeah.
But let's just say it's a benign species, and they just want to make contact, and we receive a signal 100 light years away. How is that going to impact people's life? It'll make headlines for a week, and then nothing.
And then people will forget.
Philosophically, it may affect people, but religions are going to adapt. Their theologies are going to adapt. Society is going to adapt, and people are very resilient. I mean, look at this pandemic. I have never in my life experienced, nor have you experienced, anything, even during the world wars, even during World War II. World War II affected the whole world to some extent, but not every country. There were some countries who had no part of the World War, and business pretty much went on as it could. Now think, if you send a signal back, you receive a signal tomorrow, and you confirm it as being, from an artificial or alien intelligence, and you cannot interpret it. You are in a year's time. You prepare. You have a committee, and you have a UN committee and astronomical committees, and they have a bunch of coffees and maybe too many scotches, and they think about and debate. What should our response be to this signal? They finally draft something. They use Arecibo to send it back the way it, back in the direction they think it came. They got to wait 100 years. You got to wait 100 years. The people who received the signal are going to be long dead. Your great grandchildren may be, they'll be in middle age.
Wait a minute. I just interviewed Aubrey de Grey in the previous episode, and if he is correct, they may not be dead. Because we may have reversed aging.
Anyway, they may not. But what I'm saying is that we Earthlings are going to have to wait on a response, and our attention. Think about it. Our attention spans are about that of a tsetse fly at this point. I mean, people have they cannot even sit down and read a classic novel. So why are they going to wait 100 years for a signal to come back?
Oh my God, 100 years.
They go back to going to soccer matches and going to the beach and chasing women, whatever they want to do.
I get you completely.
Sorry.
Yeah, I agree completely. Yeah, there's no. Yeah.
So I think, but I don't. This is one thing I'm very much at odds with the SETI community. They're always wringing their hands. Oh, how would people react? I think that's a load.
That's interesting. That's very interesting perspective.
Because I don't think it would have that big of an impact.
Okay, that's very interesting. But now let me ask you something else. I'm really curious about that connects with that. Do you think if we ever come in contact with a new kind of life form that is based on, for example, a different type of chemical arrangement, different to ours, do you think that there exists the possibility that we may actually miss the presence of other life forms that are in front of us just because they have different chemical arrangements, for example, or different, aspect, whatever, and we just don't recognize them. We don't see that they are there. We cannot detect them because they are based on a different arrangement to us. What do you think? Is this possible?
I see your point. It's kind of like the Andromeda Strain premise where, the Andromeda Strain, the Michael Crichton novel.
Oh, the novel.
The movie, which at the time was fascinating. I mean, now the movie is a bit dated, but it's based on exactly what you're saying. That it's a life form that is based on a chemical structure that is totally different from what we know of RNA and DNA. I think that we may, there's always a possibility that we may miss opportunities to identify life forms or microbial life that we don't recognize as life. But I think if if you talk to a lot of astrobiologists, they seem to think that that the nucleic acids that are so necessary for life here on Earth are probably going to perpetuate themselves in some other in a similar format across the cosmos. Something like some sort of biological base for life in which life can reproduce and transfer information and have a structure. Now, but it's fascinating. I mean, it's a fascinating point, and I think that there are people now who are doing research on artificial life, who are trying to create artificial life here on Earth. I think we'll know more about this issue that you raised, maybe in 10 years' time when people have actually made artificial life.
Yeah,
but
that's
at this point, if you go into a textbook, it's kind of like that. When I was writing my book on extrasolar planets, at that time, people had varying different definitions of the definition of a planet, and so if you look at the definition of life in a biology book, if you go to a basic high school level biology book, you're going to get a pretty simple explanation of life. But if you scratch the surface of this definition, you're going to find debate, even among astrobiologists, of what constitutes life. I mean, that the definition of life is still debated at biology conferences, astrobiology conferences. I mean, that sounds crazy. The other thing is, I mean, it kind of comes back to history as well. If you go to a basic textbook, 50 years ago, Western textbook in English, the kind of textbook that I read in high school about history of the age of discovery, you'll read that, Magellan circumnavigated the world and yada, yada, yada. And they kind of brush aside the fact that, his goal wasn't really to circumnavigate the world. His goal was to claim the Spice Islands for Spain by going on a westward voyage. And he actually kind of freaked out when he realized that it was in the Philippines, and that the Spice Islands were on the Portuguese side, and his life was basically ruined. And he started fights with the local Filipino people at that point, and was killed on the beach. And so, and if you went to a historical, I guarantee you, this is the thing about science that people don't realize. You scratch the surface on any given topic, science, history, whatever, where people are doing academic research, and you're going to have disagreements. And I guarantee you went to a historical conference and you brought 50 historians together. They would all probably dispute what I just said to some extent. They had details that differed, yada, yada, yada. And the same goes for biology. The same goes for astrophysics.
This is very interesting. You're telling us that even in the main historic topics, if you bring the experts, if you scratch the surface, we're going to find disagreements, different perspectives.
Absolutely, absolutely.
So it's very hard. It's very hard to pinpoint the actual truth, if such thing exists, if it exists.
That's right.
Yeah.
Right. Well, look at. I mean, a prime example was. In 1996, I believe, I was preparing for I used to be a tech correspondent based in Paris for the Financial Times. I wrote technology articles. That's how I started in science. And I was going to interview the fellow, I've forgotten I won't embarrass myself, but I don't remember his full name, who was doing initial designs for the overwhelmingly large telescope, which was going to be the follow-on telescope to the very large telescope at the European Southern Observatory in Garching, Germany, outside of Munich. And so the night before I was to interview him, I was fascinated by this prospect of an overwhelmingly large telescope in Chile. Okay. It was going to be 100-meter telescope.
Wow.
Now they have since, I applaud ESO because they're actually under construction now is the European Large Telescope, which is 39 meters.
Yeah.
The OWL, the OWL, the Overwhelmingly Large Telescope at 100 meters, is temporarily. It's probably going to happen, but right now they're working on the 39 meter. Okay, to make a long story short, I turn on CNN at a hotel in Garching, Germany, the night before I interviewed this astronomer at ESO, and there's Bill Clinton on the White House lawn announcing our scientists have detected what they think is a microfossil in a Mars meteorite found in Antarctica, the Allan Hills.
The Allan Hills.
Meteorite.
Yeah.
And fast forward, they cut to this live press conference, and they make the announcement, and there you go. Some of the scientists on the panel interpret this as a microfossil, and then there are a couple. No way, this is a microfossil.
I remember that. Yeah.
And since people now accept it took a few years, but I don't think there's anyone now who believes that what was first thought to be a microfossil in the Allan Hills meteorite is now a microfossil. They think it's an artifact. Okay, so there you go.
I remember I was so enthusiastic. I really wanted it to be so much a microfossil.
And I bet, but yeah, of course. But I bet by the same token, if you had a panel, if you had a session at the AES meeting next year, and you had two people who wrote papers saying that, in fact, these are the reasons why it is a microfossil, they could have a big debate about it. So that's what I say. You scratch the surface, you're going to find disagreement.
Very interesting. Very. You really make me think. Is almost like a fractal in life. When you scratch the surface of anything, you begin to find it's like the atom. The atom looks like just a simple thing. You start to scratch, and you start to find the quarks and all this,
exactly
all this mess, and then more, and then the quantum, the uncertainty, and everything. That's interesting. Very interesting. So already approaching towards the end of our trip, Bruce, I want to go back closer to the solar system and talk about another thing that people don't think a lot about. We look at the sky and we see the meteors, and then there are the asteroids in the solar system.
Right.
A lot of people are thinking that asteroid mining is going to allow humans this mining of the resources of the asteroids, like water and minerals. It could actually help us to solve a lot of problems of Earth. What do you think about asteroid mining in terms of when is it going to be viable, and is it really going to help humanity a lot?
I think eventually it will, but we haven't done it yet. There was a company called the startup called Planetary Resources here in the Seattle area, and I have had no contact with them. But they were very big advocates of asteroid mining, and but I hear nothing about them now. I mean, that seemed to have been very popular with startups, 10 years ago or 5 years ago. At least, I think that all was trending 10 years ago. Yeah, as a way to commercialize space flight and space exploration. I personally think the easiest way to commercialize space travel is to simply there are people. I mean, there are 7 to 8 billion people in this world, and there are a lot. There are people with a lot of money, even after this pandemic. And who knows what's going to happen with the pandemic? Because I can tell you that things are not normal here. I don't know what they're like in Spain. You suffered greatly. And nobody knows, if we're going to become as a society more inwardly focused, let's solve our problems here. Let's make sure we don't have another pandemic. If nobody knows how the pandemic is going to affect the future of the global economy, is society going to become more inwardly focused to the point where they don't value space travel as much. I mean, that's an interesting topic. But to answer your question, I think that, the pandemic aside, I personally think that if there were a way to easily allow, healthy humans to train for a circumlunar trip around the moon, a sightseeing trip, in the same way that you can now, I believe in Christchurch, New Zealand, and you can, go on a 10-hour flight over Antarctica without ever landing, and just to see the sights. I think that, there are a large number of people who could afford maybe $1 million or $2 million to buy a ticket on a translunar flight, just to, go close enough to an Apollo 8 style translunar flight, and they would pay for that. And, that would probably be a profitable way to start the, trips to the moon. I mean, so as far as asteroid mining goes, I think eventually, yeah, I think, but I don't see that happening frankly, in a viable way for at least another 50 or 100 years.
Okay. 50
I mean, the one last thing before we land or finish our journey, we have to realize that, I'm actually disappointed in what's happened since the Apollo era. I'm actually disappointed. I think that we could make a lot more progress now by sending every 2 years to Mars, every 26 months, when we're, the launch window is optimized. If we would just, send robotic probes, rovers probes to Mars, and sample return missions, and use our robotic expertise to explore the red planet, you could do that at a fraction of the cost of a crewed Mars mission, and I think that's something to consider. Now, on the other hand, I think for scientific reasons, we should be back on the moon. We should have been back on the moon decades ago, and using the far side as a platform for, low frequency radio astronomy and for optical astronomy as well. So anyway.
Very good, very good. That's a very interesting perspective. And let's hope that things will accelerate from now on, and that even people eventually will be able to just casually say, let's spend the weekend on the moon. How far do you think is such thing? Oh, let's go spend the weekend on the moon. Is that
right? That was one of your questions, and I was thinking about that yesterday.
Is that 20 years away?
That the earliest we'll be back on the moon is 2024 with the Artemis mission. Okay, we're 2020, 2024, and I'm not even sure we're going to make that deadline. I would wager that 2024 deadline is going to be pushed back at least a year due to the pandemic, maybe 2 years. Okay, so, and then let's say, just going for a short duration missions to the south, the lunar pole, let's do 2 or 3. I see that's going to happen probably by 2035.
Okay, it's not close. We ain't going to spend the weekend on the moon anytime soon.
I think the earliest you could see that would be 2050, 2060. To be
honest.
Oh
my God, forget it then for now. All right, Bruce, we're about to land. Last question for you. To finish this amazing conversation, tell us, what do you have when you look, in the space industry and everything, what is your dream, or what would you like? I mean, you've told us a little bit now, but what would you really like to see happening in space in the next decade, let's say? What would be the most exciting thing that could be really beautiful to see happening in the next 10, 20 years,
Right. Well, I'd like to see us put a crew on Mars. I'd like to see a sample return mission, a robotic sample return mission from Mars, which is in the works.
Yeah.
And I'd like to see some sort of semi-permanent or permanent settlement on the lunar surface. I'd like to see optical and radio-based astronomy on the far side of the moon. And I'd like to see space tourism. The other thing I'd like to see is a grand space-based interferometers. I want the engineers to solve that so that we have a much better chance of detecting microbial life from extrasolar atmospheres. And I know I kind of cast aspersions on that at the top of this conversation, but that doesn't mean I'm not interested. I think we really need to suss out, where we stack up within 1,000 light years of Earth, with some precision, where are the best extrasolar Earths, which seems the most likely candidate for life, and then target those with SETI somehow. I mean, listen, at least passively listen. And the SETI people are doing that. I'm more sanguine about detecting, if you're going to detect any signal, I'm more sanguine about detecting laser signals in the infrared from such a civilization, or by somehow detecting the byproducts of their propulsion mechanisms, or radio leakage or something like that. I'm not sure that that extraterrestrials are going to have the same attitude that we do of wanting to communicate. We are gregarious people, and you need to think about that. I was not to bend your ear, but I just want to make one more point. Yesterday, a Brazilian friend, or a couple of days ago, sent me a GIF of a iguana, and iguanas are not socialized creatures. They are very territorial, but they do not need other iguanas. They prefer to be alone. And so think about, maybe you have a civilization. They prefer to be alone. They're not socialized.
Yeah, maybe they are not social. Good point.
They're not social. We arguably evolved from chimpanzees who
gregarious.
The standard paradigm is that we came out of the trees overlooking the savannah, and gradually became bipedal, and so we are social animals. We need other people. That's why this pandemic has been so difficult. Let me ask you a question. So, what's your own view of how the pandemic is going to affect space research, space travel, the desire to travel? Are we going to become more inwardly focused?
That is a brilliant question. I mean, I don't know, because the entire pandemic thing has been such a surprise for everybody and so unpredictable. But I personally love to travel, and it's going to be very interesting. They say that domestic travel is going to increase a lot because people are going to be a little bit more careful about traveling far away. So they are predicting that domestic travel is going to increase. Maybe international travel is going to decrease. But I don't know, the big question is, connecting with what you said before, is not so much what's going to happen in the near future, but what's going to happen in, let's say, a year or two. Because as you said, our attention span and our memory, it just goes very fast. So maybe, who knows, maybe in a year or two, everything will be back completely to normal. I mean, for me, this is the big question. Is there going to be, for example, I think it was beautiful to see the impact on the atmosphere, less pollution, people being more conscious about climate change. But is this going to last? Or maybe in a year, everybody will have forgotten completely and nobody gives a damn anymore, So for me, this is the biggest question. But anyway, enough of me talking. Listen, we are landing, Bruce. We are landing. So before we land, I want to remind everybody that Bruce has a beautiful book published on Amazon, right? The name of the book is Distant Wanderers, correct?
The Search for Planets Beyond the Solar System. It was one of the earliest books on exoplanets, and it's still in print. It's not a recent book, but it's a good overview of the subject, and
one of the first books on that.
I even go back and consult it myself from time to time.
Yeah, we're gonna put the link on the description of the video for people that wanna get it on Amazon. Perfect. And also,
but let me just tell you, the best way to follow my work at the moment is still on Forbes.com. Forbes, Forbes.com. I have my own page there, and in which I post, and you can follow me also on Twitter at @bdorminey, and also on Facebook, my journalist page, my Distant Wanderers book page, and also my journalist page, Bruce Dorminey. So I just want to thank you so much. It means so much to have someone who says that they love your work and your ideas. That really validates it, and readers like you and followers like you is what makes it all worthwhile. So Javier, I really appreciate it.
Thank you, Bruce. I have really enjoyed reading your articles and really enjoyed this conversation so much. Thank you so much, and have a great, for me, great rest of the trip, and you will have a great rest of the day on Earth. Thank you.
Okay,
Bruce.
Thank you so much.
Thank you so much.
Thank you.
Thank you for following the Beyond podcast. If you enjoy it, subscribe on YouTube and support it in other channels like Patreon and others. And hope to see you soon at the Beyond podcast. Thank you.